Okay, 33. They give you the graph of f prime. Which of the following statements is true? Like this statement is useless. The graph of f prime, the derivative of a function f. Yeah, you better know that f prime is the derivative of the function f. So they just throw that in because they know that the more words they put on the problem, the more confusing the problem tends to be. Okay? The domain of f is the open interval from 0 to d. That also is not really anything that you have to worry about too much. They're just saying don't think of f going further than what you see. This is f, don't look any further. Which of the following statements is true? There's never more than one correct answer. If there's more than one correct answer, they'll do the format where they'll say, which of the following statements is true? And then they give you options I, Roman numeral 1, Roman numeral 2. Just trying to find an example real quick. We don't have one in this packet. There we go. So if they give you this format, then yes, several of these can be true. But in 33, where they say which of the following is true, it's only going to be one of the 5. So it says f has a local minimum at x equals c. Okay. You don't, somebody asked if you can use the laminated reference, not the laminated, but the sheet protected sheet on the test. No, the test doesn't allow any notes, so I can't allow notes either. So, but you do use this heavily. Right here you use it. Let's see, f has a local min. When f changes, decrease to increase. So I'm looking to see when f does this. Which means I need to see f prime doing this. So at x equals c, I observe the y-coordinates of f prime being positive, and then the y-coordinates being negative. It's backwards. So that's why this is false. A good test of your ability to make sure you're understanding the concept. I'll pay you. Raise your hand. What simple change can be made to this which will make this a true statement? Right? What simple change can be made to A which would make A true? It's a really good test of your understanding versus memorization. Let's go, Stephen.
Local max.
So if this had said local max, who had their hand raised and knew that? Point, 2 for Stephen. There's another way to make a change here that would make it work. I can just leave it as f has a local minimum, but there's something else that you can change that would also make it a true statement. Okay, everybody know? Let's go, Camden.
Has a local minimum at x equals
So if I change this to A, now it is a true statement. So 2 for Camden. Who else had their hand raised and do it? Point. And you need to talk about it some more. Cool. Local maximum at B. F prime has a local maximum, but F doesn't have a local maximum. So that's false. The graph of F has a point of inflection. Raise your hand if you know what this symbol means. This is not the kind of class where you can kind of like many classes, like you don't know something, you can just fake your way through it for most of the year. You have to know what that means. What does f of a mean? Let's go Trey. So it's the y-coordinate of which function? So it's the y-coordinate of f.
Well, yeah.
There, you're good. There you go. So this is the y-coordinate of f at x equal a. They're just telling you, here's f prime, But if you were looking at f, and you went to, on f, whatever f looks like, and you got to an x-coordinate of a, and you went to the y-coordinate, well, that y-coordinate, the symbol that represents that y-coordinate is f of a. And how many knew it before he said it? Point, 2 for check. And then you need to talk more about it.
So it's not saying that A is the same in each case, it's just saying that it's, right, it's not saying it's like the same value. So if A and the x coordinate would be, like if it was 2, then f of A, it's not saying it would be 2, but it's just saying where that coordinate is.
Yes, let's draw a quick picture. So the example you used, Josie, would be this. So I've got a graph. On the graph of f itself, if a happened to be an x value of 2, the y-coordinate could be anything. If we don't know what number we should associate with that y-coordinate, we can just say, hey, we'll just call it f of 2. It means the y-coordinate right at that spot. So we can label that value as 2 comma f of 2. Does that answer your question?
Yeah.
2 points. Anybody else? Cool, so go back to here. Graph of f has a point of inflection at x equal a. So f has a point of inflection when f changes like this, or the other way around. So concave up to concave down, or vice versa. So we're looking to see if f's going to do this. Therefore, we need to see if f prime will do this. Now at x equal a, f prime is certainly not changing from increase to decrease. So that doesn't work. Question? I'll pay a full ticket for this one. There is something changing from increase to decrease at x equal a. We actually talked about it today. You can see this. This is a really good test of your understanding of what we talked about. Something, f itself is, like f prime is not changing increase to decrease at a, because this is referring to y-coordinates. And as you follow the y-coordinates along here, the y-coordinates just increase. They become greater and greater. But something along here is changing at about a from increase to decrease. I'll pay a full ticket for all we know. 10 tally marks in one fell swoop. Is that the right phrase? Fell swoop. Old-fashioned phrase. Let's go tally.
F is changing from increase to decrease at that point.
So we look here. Because f prime is changing from negative values to positive values, that means f itself is definitely changing from, oh, it's the other way around though, isn't it? Yeah, it's okay. It's good. Your answer is a good one. He's saying that, oh yeah, that would make f changing from decrease to increase at that point. Raise your hand if you can see that. Come on. Point, 2 per column. We're looking for the other way around. It's a really good answer. So what's changing from, like the question says, the graph of f, we'll skip the question for a minute. I just want to know what's changing from increase to decrease at a. What is changing from increase to decrease? Let's go, Seth.
So the acceleration.
2 points. There technically is no acceleration in the picture because it's not a story. You could think of it as the second derivative. That's better. So what Seth is noticing is, right here, f prime is concave up. Now f prime is switching to, kind of in this vicinity, concave down. If f prime is switching from concave up to concave down, that absolutely means that F double prime will switch from increase to decrease. So show me your hand if you honestly had your hand raised, knew that before Seth said it. Hello? Scott? Charlie? Anybody else in this? Jake? Okay. There's still something else. I'm going to erase this so we can see better. There's something else that is changing from increase to decrease as you follow this path at approximately A. We talked about it today. Anybody? Please.
I don't know if this is right, but is it the velocity? Wait, no, you just said that, never mind. 'Cause
Yeah, you wouldn't want to use velocity. It's okay. Yeah, we don't want to mix up. Like I put on the chart here. Everybody look. Everybody look. I put on the chart a V here for F prime. Please don't think that V and F prime are the same thing. I could have easily put a V here. And then the A would go here. Okay, so it's relative. It's not absolute. Don't memorize that as a connection. But there is something that is changing from increase to decrease. Can we?
The tangent slopes?
Tangent slopes. We talked about earlier today, when a curve is concave up, as you follow the slopes, this tangent will have a positive value. This tangent will have a more positive value. More positive value. If you keep going, they stop becoming more positive, start to become less positive. It's right here. Along this section of the curve of F prime, the slopes of F prime are increasing. F double prime is the slope of F prime. So that's why there's an I here. Then when F prime becomes concave down, those slopes begin to decrease. That's what concave down means. So. You else have a hand raised when Camden raised your hand? I see them. Okay. F has a point of reflection at B. At B, F prime is changing, increase to decrease. There it is. That's where F will have a point of reflection. Questions? Please, Trey.
I'm just a little confused. So at point A, it goes from negative values on F prime to positive values. That means like local, that would be a net minimum. Would that mean that that changes the cavity or no?
Oh. Suddenly it's time to give out tickets for everything. You listen close to what Trey asked. It is definitely true that at x equal a, so it's right here, at x equal a, F prime, delta means change, changes, pen's not working, hold on. Negative to positive. So, F changes decrease to increase. So F has relative min at x equal point A. You need me to explain the Greek. That's what you're saying, right?
Yeah.
Okay. That doesn't mean that F changes concavity there. It could, but it doesn't mean it has to. In fact, I would say it's rare or near impossible, actually. Don't associate concavity with relative mins and max. Well, When f prime has a relative min or max, f has a change in concavity, for sure. But something that people have trouble with a lot is they'll think that because f is concave up, there must be a relative min there. Don't associate those two. They don't have to be true. Here's a function f that is always concave down, and yet that function f still has a relative min.
Oh, okay.
So don't think of concavity as being the same as relative min or max. That will cause a mistake. It's one of those sometimes true. In fact, it's often true. It's just not always true. And the test writers, that's what they're looking for all the time. Is what's something that's like 99% of the time true, but that 1% it isn't, and then they get you on that one. So just memorize the things that are absolute truths. So, good question. Anybody else on this one? Cool. Okay.